So now you know what features blockchain has. It is immutable, it's distributed, it's decentralized, and consensus is there. But how does it all work? I gave you an analogy of the notebook where the pages and every entry is a transaction. So how does it look like in a real blockchain scenario? So imagine a block. So you have the first one is the block header, and what happens is every block will have the block number and your data and the previous hash. That means whatever is in the previous block, it hashes everything. Hash is nothing but every content is just they are just encrypted using SHA-256 algorithm. Right now they are using this, but it can be more something else in the future. And you have a very encoded message, which I'll show you how it works. But the important part here is the Merkle tree that I told you. So what happens is you cannot have every transaction. Every transaction is hashed, and then that hash of the transaction is also hashed together, and all these hashes create a Merkle tree. So just for example, transaction 0 on the left side, you see transaction 0 and transaction 1. So you have hash 0 of the transaction 1 and hash 1 of the transaction 1, and this creates hash 0 1. So that means all the transaction will create these kind of pairs. So you all the transaction will come together, and at the end you will have hash 0 1 2 3. That will be the Merkle root that you will put on the blockchain. So to make it more clearer, you see something like this. So what happens is block 10 will have the previous hash, which is the hash of the block which was preceding it, the timestamp, the transaction root is the Merkle tree, Merkle root I am talking about, and the nonce. I'll tell you what nonce is. So you see, has transaction 1, transaction 0 becomes hash 01, transaction 2 and 3 becomes hash 23, and then the transaction root that you see will be hash 0123. So how it works is basically now a better picture is a block. You have the block header, you have your data, that is the transaction that you are doing. It's whatever data you might have. Think simple that you have some coins and you have to transfer it from Alice to Bob or whatever. So data is Kirill has these coins and he gave it to Hadlin. Kirill gave it to eBay, and then he gave Hadlin some more coins. Then there was a previous hash, and then there is a hash of this whole block. That means block header, data, and previous hash coming together to create a hash, and this hash will go to the next block. So what is missing here? You will say, okay, fine, it's very easy. You hash everything, and that's the block. Then what's the big problem there? What is mining all about? There comes nonce, which you see in the right hand side, because you cannot tamper with the data. So what you can do is create a variable, a random which is number used only once. Nonce is number used only once, is something that you can change, but you cannot change everything else. What will happen is this: if you change the nonce, the red hash, the complete hash of the block will change. And why we do this is because that is what proof of work is all about. You have to guess this nonce. So every miner in the world, they are just sitting in, or their computer just running around to solve this cryptographic puzzle to find this nonce. So when you find this nonce, you come up with a target. That is the difficulty we set, that you have to get a certain type of hash. This hash that you see in front of you is not correct because it is not starting with 000. So what happens is, now if you know what the block looks like and what the content is, like the data, the header, the previous hash, the next hash, the hash of the block, and the nonce. So now if you have this in mind, what happens when you solve a cryptographic puzzle? So now you see there is a difference between this slide. Just note down the hash, how it starts. It starts with the number, right, on the left hand side. This is the leading side I'm talking about. So left hand side 82b5, 82b5. This was just making the presentation. This is not correct. Normally every hash should have a leading zeros. That is defined every 2 weeks, or every time Bitcoin decides, Bitcoin protocol algorithm, Bitcoin blockchain decides what will be the difficulty, the target that week. Will it be 4 zeros, 5 zeros, 6 zeros? That is the target, that is the difficulty that you set. Then so one thing you should know, take away from this is, like, okay, the hash should always start with leading zeros, otherwise it's not a correct thing. So once you have that, you can play with the nonce. So I'm just showing you the chain of why it's called blockchain. Again, it's a chain of blocks. Blocks are like this, and every hash leads to the next one, and it is linked with the previous hash. But we are trying to understand what is proof of work. Proof of work is all about guessing the nonce and getting to the target hash of 4 leading zeros. How that works? So what will happen, you will see every time the SHA-256 is 64-digit long. Whatever you write, you will always get 64 digits at the end as your encrypted message. So what happens is, if you can imagine, you have 60, because it's a hexa decimal. So every number has 16 different possibilities. So you have 16 to the power of 64 possible hash values. So people think that it's very easy. No, it's not. So what happens is, when Bitcoin sets a target, so you see at the bottom. Why at the bottom? Because more the zeros you put, it will come to the bottom, and less zeros FFFFF will be at the top. So I'm saying, let's set a target of 4 zeros. The difficulty is, you have to guess a hash which has 4 zeros. So that belongs there, but it's not something that you can just guess like that. And so you see example 23. If I guessed a nonce of 23, it is on the very top, because you will get a hash of FFFFF something. If you guess 21, you came down. So you think it's very easy. Let's keep going down. But if you do 22, again it's going down, and you put to 143, it's going. So it's very random, and that's why it becomes very difficult. It can go up to billions and billions, the nonce that you can guess. So once you guess something that gives you a hash with the target, that means 00 starting with 4 zeros, you come to the target line, and the person, the machine that guesses is the first, is called the golden nonce, and he gets the prize. You must have heard of that. He is the miner, and he will get the Bitcoin. Right now it's 6.25 every. I don't know, there is a duration. I'm missing it, but it halves. So it was 12.5, and now you get, the miner gets 6.25 Bitcoin if he guesses the correct nonce. So that is the price of mining and making it work. Otherwise, hashing is very simple, but guessing this nonce is takes the power, takes the energy, and not everyone does it. So that's the whole, in a nutshell, what proof of work is all about. So I think there is a lot to digest, I guess. So I think this is the perfect time to take a break. Yes, yeah, I think so. Okay, so a little bit more technicalities. I think if people didn't understood what I was talking about, maybe this demo will help them. What is SHA-256? What's the whole encryption looks like, and that will maybe help you a little bit. So I'll take 5 more minutes maybe to explain this. So what you see in front of me is, I just wanted to show what SHA-256 looks like. So you see this is the 64 digit that I'm talking about. You don't care whatever you write, how much line you write, whatever, it will always be 64 digits. That's why the whole probability, the whole nonce thing that I was explaining, you can do whatever we want with the data. And it's not just about nonce. When I talk about the hash, this is the hash. So if you have a picture, a PDF, whatever you name it, any line, any format, I can just copy paste. Let's say this kind of format. If I want to copy and paste, it's always going to be the same size. This is the SHA-256 that you should imagine. Like when you hash something, your data, any format, this is what you get. So on the blockchain, what you store is the hash. So it's a reference, and you can imagine that if you hash something and you store it somewhere else, you can store the reference on the blockchain, and it can go search via this reference somewhere else. So once that is clear, what hash is, this is what the block is. So I was telling you, this is the block header, this is the thing, and normally there is no data in it, but it has come up with this nonce. You see, this has 4 leading zeros. That is something that you have to always create. So there is no data in it. But if I change the data, you see it becomes red. Why? Because you already see it is not falling in the target that was defined, which I explained earlier, that you have to achieve 4 leading zeros. That is the correct hash. Otherwise, we know that this is not correct. So you see this, it has become red. So I'll mine it again. Now you have only one block. So you saw the nonce change, as it is only one block, and it was comparatively very easy to find the nonce. and now the block is fine, it's green. So now you know what the block is. So what is a blockchain? So it's a chain of blocks. So now you have more blocks, and everything is green because this is the 0 0, because this is called the genesis block. So this is the beginning. This is the inception. That's why it doesn't have any previous hash. It's 0, but it has got the hash of its own. That means previous hash, data, nonce, and block. And so you see this is chain of blocks. So previous hash, this one is same as this one, and so on and so forth. So suppose if I have to store some data, something, whatever you want, because right now with no data it doesn't mean anything. Let's say that you store name and your property, whatever you want, as I said. But you see it's red now. Why? Because the hash is not as it was supposed to be. There is a rule to follow. So now you mine, you do that proof of work, so that you create, you find this nonce and it becomes green. What happens when you go back in history and change something? All red. Why? Because you see every hash that is not following the rule. So you mine this, you do the lot of work. Uh, Now it's only one chain, it's only one block, only one pair. So I'm mining it quite fast, fine. But this is how, like, if you change something, the hash changes and everything changes. So you have to mine everything and come back. So you have to use your processing power, energy to calculate this hash, the new hash, because you change the data. You can trick the system fine because it's only one chain. But what do you mean by distributed? That means it's not only me who is there, it's you, it's peer A, peer B, peer C. So there are so many people. So now what happens if I change this blockchain is corrupted now, but it doesn't mean that I cannot revalidate it. I will mine it again to get the correct hash, to guess the correct nonce. So you saw that change. Again I'll mine it. So I'll keep on mining because I have the power. Right now it's not much, so I can mine 3 blocks, and I mine 3 blocks, and I got, it's still mining. It's still finding the right nonce. Okay. So what does that mean? This means that I tricked the system and I have something else. But I told you, you have the copy of the same thing. You have the same copy of the book. And now when you see, you have something called as 85888AB, and I have something 38538, and he has 85. So there is a consensus saying that peer C and peer B has the same node but not peer A. That means he has tricked the system. This is not correct. So they will accept only these data, these transaction, this money or double spending problem that you had, this only 100 euros and not 200 euros that you wrote here. So this is how the distributed system helps. So once you know the block, once you know what proof of work, how it works, the distributed system keeps one single source of truth. So now it is not making sense to you, maybe because the data is kind of, you don't understand. So let's put it in real data terms, where Ali is sending Oli some money and Ali is sending Robin some money. So this is, if I change this, the whole blockchain will change. Everything is red. Again I can mine all this, I can mine this, and it will create the correct nonce. Then I mine the next one. I can mine this, but then the same problem. You will see the consensus is not reached because all the other nodes have a copy, and you are cheating because you are saying you have more, you have $100, but it's not correct. You have only 10, and people can vouch, or other peers can vouch for that. So that's how the whole mechanism of, you see, distributed system, blockchain with, immutable ledger. Because if you change something, the whole has to be changed, and everywhere it has to change, and it takes a lot of mining power, the energy to do that. So if you imagine in the world context, where I'll tell you, Ethereum has like if I'm not wrong, last time I checked it was 16,000, maybe it may be more nodes, and Bitcoin has even 100,000 nodes. So changing all that transaction on every node is huge. It's not doable. So now one question can arise. Okay, but who told you that I have 200? There is no accountability. So I'll show you, like, okay, first we need an account. So I have 100 euros, and then only this is the base. So again there is a genesis. So there is account. Do I have 100 euros? First, yes. Do you have? Then you can do transaction, and then the whole verification and everything. And again it goes on in the same manner. So I hope this combined with what I was trying to present makes sense, and you know a little bit about what blockchain, what proof of work, and what mining is.